Close your eyes for a moment and imagine floating in the vast darkness of space. All around you, ancient worlds dance in an eternal ballet, held together by invisible forces that have kept them moving for billions of years. This is our solar system, our home in the cosmos. Tonight, we'll journey together through this magnificent realm, discovering the wonders that lie both nearby and far beyond our blue planet. So settle in, relax, and let's begin our voyage through the stars. Our solar system was born approximately 4.6 billion years ago from a swirling cloud of gas and dust called a nebula. Picture this enormous cloud, gently rotating in the silence of space, until something, perhaps a nearby exploding star, disturbed it, causing it to collapse inward under its own gravity. As this cloud condensed, most of the material fell toward the center, where pressure and heat built to such incredible levels that nuclear fusion ignited. Our Sun was born, a glowing sphere that contains 99.86% of all the mass in our entire solar system. It's so massive that you could fit over 1 million Earths inside it. The remaining material from that ancient cloud formed a disk around the young Sun, and within this disk, particles began sticking together. Dust became pebbles, pebbles became boulders, and eventually, these grew into the planets we know today. This process took millions of years, a cosmic dance of creation happening in slow motion. Our solar system extends far beyond the planets we learned about in school. The Sun's influence reaches approximately 18 billion miles outward, to a region called the heliopause, where the solar wind finally gives way to interstellar space. This boundary marks the edge of our Sun's domain. Within our solar system, there are 8 official planets, but the number wasn't always agreed upon. For 76 years, from 1930 to 2006, we counted 9 planets, including Pluto. But in 2006, astronomers redefined what makes a planet, and Pluto was reclassified as a dwarf planet, not because it wasn't important, but because we discovered it was just one of many similar objects in its distant neighborhood. The planets are divided into 2 main families. The inner 4, Mercury, Venus, Earth, and Mars, are called terrestrial planets because they have solid, rocky surfaces you could theoretically stand upon. They're smaller, denser, and warmer, huddled closer to the Sun's heat. Beyond Mars lies the asteroid belt, a ring of rocky debris that marks the boundary between the inner and outer solar system. This belt contains millions of asteroids, from tiny pebbles to Ceres, a dwarf planet nearly 600 miles across. The outer 4 planets, Jupiter, Saturn, Uranus, and Neptune, are gas and ice giants, massive worlds with no solid surface to land on. These planets are enormous compared to Earth, composed primarily of hydrogen, helium, and various ices. If you could somehow place all 8 planets side by side, Jupiter alone would account for more than twice the mass of all the other planets combined. Everything in our solar system orbits the Sun in the same direction, counterclockwise if you're looking down from above Earth's North Pole. This shared direction is a fossil from our solar system's birth, evidence of that original spinning cloud from which everything formed. The planets also orbit in roughly the same flat plane, like marbles rolling around the rim of a giant, invisible disk. Let's draw closer now to the heart of our solar system, the Sun itself. This magnificent star is not solid like the Earth beneath your feet, but rather a sphere of plasma, a state of matter so hot that electrons are stripped from atoms. The Sun's surface temperature reaches about 10,000 degrees Fahrenheit, but this is cool compared to its core, where temperatures soar to an astonishing 27 million degrees Fahrenheit. Deep within that core, an incredible transformation occurs every second. The Sun converts approximately 600 million tons of hydrogen into helium through nuclear fusion. This process releases the light and warmth that makes life on Earth possible, energy that takes thousands of years to travel from the Sun's core to its surface, but then only 8 minutes and 20 seconds to reach our planet. The Sun rotates on its axis, just like Earth does, but because it's not solid, different parts rotate at different speeds. The equator completes a full rotation in about 25 days, while regions near the poles take closer to 35 days. This differential rotation creates complex magnetic fields that twist and tangle, sometimes erupting from the surface as solar flares and coronal mass ejections. These eruptions send charged particles streaming through space in what we call the solar wind, a constant flow of particles that travels at roughly 1 million miles per hour. When this solar wind encounters Earth's magnetic field, it creates the aurora borealis and aurora australis, those ethereal curtains of green and purple light that dance across polar skies. Now, let's visit the innermost planet, Mercury, a world of extremes. It's the smallest planet in our solar system, only slightly larger than Earth's moon, and it orbits closer to the Sun than any other planet, just 36 million miles away on average. Because of this proximity, Mercury races around the Sun faster than any other planet, completing an orbit in just 88 Earth days. But here's something curious. While Mercury orbits the Sun quickly, it rotates on its axis very slowly. It takes 59 Earth days for Mercury to complete one rotation. This creates a strange rhythm where a single day on Mercury, from one sunrise to the next, actually lasts 176 Earth days, or 2 Mercurian years. Time moves differently there, in ways that would feel dreamlike and strange. Mercury's surface is a scarred landscape, cratered by billions of years of asteroid and comet impacts. With almost no atmosphere to burn up incoming objects or erode these ancient wounds, the craters remain as permanent records of violent collisions. Some of these impact basins are enormous. The Caloris Basin stretches 960 miles across, created when an object the size of a small state struck the planet billions of years ago. Despite being the closest planet to the Sun, Mercury isn't the hottest planet in our solar system. That distinction belongs to Venus, our next destination. The side of Mercury facing the Sun can reach 800 degrees Fahrenheit, but without an atmosphere to retain heat, the night side plunges to -290 degrees Fahrenheit. It's a world of fire and ice, depending on which way you're facing. There's something else surprising about tiny Mercury. It has a magnetic field, though much weaker than Earth's. For a small, slowly rotating planet, this is unexpected. Scientists believe Mercury must have a large iron core, making up about 85% of the planet's radius, which generates this magnetic field. This little world, so close to the Sun's fury, shields itself with its own protective bubble, a testament to the mysteries that even the smallest worlds hold. Continuing our journey outward from the Sun, we arrive at Venus, the second planet and Earth's closest planetary neighbor. From Earth, Venus shines brighter than any star in our night sky, so brilliant that ancient civilizations across the world noticed it and wove it into their mythologies. The Romans named it after their goddess of love and beauty, captivated by its radiant glow. Venus and Earth are often called sister planets because they're remarkably similar in size. Venus is only about 400 miles smaller in diameter than Earth. They formed from the same region of that ancient disk of dust and gas, born as cosmic twins. Yet despite these similarities, Venus took a dramatically different path, becoming one of the most hostile environments imaginable. The surface of Venus is hot enough to melt lead, with temperatures hovering around 900 degrees Fahrenheit, hotter than Mercury, despite being nearly twice as far from the Sun. This intense heat is trapped by Venus's incredibly thick atmosphere, composed of 96% carbon dioxide with clouds of sulfuric acid. It's a runaway greenhouse effect, a cautionary tale written across an entire world. The atmospheric pressure on Venus's surface is crushing, about 92 times the pressure at sea level on Earth. Standing on Venus would feel like being 3,000 feet beneath Earth's oceans. The Soviet Venera probes that landed on Venus in the 1970s and 80s survived only minutes in these extreme conditions before being destroyed by the heat and pressure, but they sent back the only photographs we have from the surface of another planet besides Mars. Venus rotates in the opposite direction from most planets in our solar system, spinning clockwise when viewed from above. Scientists call this retrograde rotation, and we're still not entirely sure why Venus spins backward. Perhaps a massive collision early in its history knocked it askew, or maybe gravitational interactions with the Sun slowly reversed its spin over billions of years. Like Mercury, Venus also rotates remarkably slowly on its axis. A single day on Venus, one complete rotation, takes 243 Earth days, which is actually longer than Venus's year of 225 Earth days. This means that on Venus, a day is longer than a year. The sun would rise in the west and set in the east, and if you could see through those thick clouds, you'd watch the sun creep across the sky for months at a time. Beneath Venus's thick cloud cover lies a landscape of vast plains, volcanic mountains, and unique features found nowhere else. There are enormous shield volcanoes, some taller than Mount Everest, and strange formations called coronae, circular structures created by hot material welling up from deep within the planet. Venus is geologically active, its surface shaped by volcanic processes that may continue even today. Now we come home, to Earth, the third planet from the Sun and the only world we know of that harbors life. Earth orbits at just the right distance from the Sun, not too hot, not too cold, in what astronomers call the habitable zone, or sometimes the Goldilocks zone. Here, water can exist as a liquid on the surface, a crucial ingredient for life as we know it. About 71% of Earth's surface is covered by water, giving our planet its distinctive blue appearance from space. This water exists in a delicate cycle, evaporating from oceans, forming clouds, falling as rain, and flowing back to the seas. It's a system that has operated for billions of years, shaping our climate and making our world the oasis it is. Earth is the only planet in our solar system with large bodies of liquid water on its surface, though as we'll discover, other worlds hide water in unexpected places. Earth has a companion that has watched over us since ancient times, the Moon. Our Moon is unusually large compared to Earth, about 1/4 the diameter of our planet. Most moons in the solar system are tiny compared to their parent planets, but ours is substantial enough that some astronomers consider the Earth-Moon system almost a double planet. The leading theory for the Moon's formation is both violent and poetic. About 4.5 billion years ago, when Earth was still young and molten, a Mars-sized object called Theia collided with our planet in a cataclysmic impact. The debris from this collision was thrown into orbit around Earth, where it gradually coalesced to form the Moon. In a very real sense, the Moon is made from pieces of the early Earth, forever bound to us by gravity and shared history. The Moon is slowly drifting away from Earth at a rate of about 1.5 inches per year. Billions of years ago, it loomed much larger in our sky, and its gravitational pull created enormous tides on the young Earth. As the Moon recedes, Earth's rotation gradually slows down. In the deep future, billions of years from now, Earth and Moon will become tidally locked, each showing only one face to the other, frozen in an eternal gaze. Leaving Earth behind, we travel to Mars, the fourth planet from the Sun, a world that has captivated human imagination for centuries. Mars appears reddish in our night sky because its surface is covered in iron oxide, rust. The entire planet is essentially a rusty desert, colored by the oxidation of iron-rich minerals over billions of years. Mars is about half the size of Earth, with a diameter of roughly 4,200 miles. Despite being smaller, Mars has some of the most dramatic geological features in the entire solar system. Olympus Mons, a shield volcano on Mars, rises about 13.6 miles high, nearly 3 times the height of Mount Everest. It's the tallest planetary mountain we know of, a monument to volcanic forces that shaped Mars billions of years ago. The planet also hosts Valles Marineris, a canyon system so vast it would stretch across the entire United States. This immense scar in Mars's surface is over 2,500 miles long, 120 miles wide in places, and up to 4 miles deep. If you stood on one rim, the other side would be beyond the horizon, lost in the curve of the planet. Mars has 2 small, irregularly shaped moons named Phobos and Deimos, Fear and Dread, named after the companions of the Greek god of war. These moons are likely captured asteroids, pulled from the nearby asteroid belt by Mars's gravity. Phobos is the larger of the 2 but still tiny, just 14 miles across at its widest point. It orbits so close to Mars that it completes 3 full orbits every Martian day. Phobos is gradually spiraling inward toward Mars, drawn ever closer by gravitational forces. In about 50 million years, it will either crash into the Martian surface or, more likely, be torn apart by Mars's gravity, creating a spectacular ring system around the red planet, a temporary ring that will last for millions of years before the debris eventually falls to the surface. Evidence suggests that Mars once had a thicker atmosphere and liquid water flowing across its surface. Ancient riverbeds, lake deposits, and minerals that form in the presence of water tell the story of a warmer, wetter Mars billions of years ago. What happened to that water? Some evaporated into space when Mars lost most of its atmosphere, but much of it still exists, frozen beneath the surface and locked in the polar ice caps. Mars holds its water close now, hidden beneath layers of dust and time, waiting. Between Mars and Jupiter lies a vast region filled with millions of rocky remnants from the solar system's formation, the asteroid belt. This ring of debris orbits the Sun at distances between 200 and 370 million miles, a frontier between the small rocky worlds and the gas giants beyond. Despite what science fiction often portrays, the asteroid belt is mostly empty space. If you were traveling through it, you'd likely need to search deliberately to find an asteroid. The asteroid belt contains millions of objects, but all of them combined would form a body only about 4% the mass of our Moon. The largest object in the belt is Ceres, a dwarf planet about 590 miles across. Ceres is large enough that gravity has pulled it into a spherical shape, and beneath its dusty surface, scientists believe there may be an ocean of liquid water, hidden away in the darkness between worlds. Most asteroids are remnants that never managed to form into a planet. Jupiter's immense gravity, stirring and disturbing the region during the solar system's youth, prevented these scattered rocks from coalescing. In a sense, the asteroid belt is a planetary ghost, the planet that never was, forever fragmented by Jupiter's overwhelming presence. And what a presence Jupiter has! The fifth planet from the Sun, Jupiter is the undisputed king of our solar system. It's so massive that it contains more than twice the mass of all the other planets combined. You could fit 1,300 Earths inside Jupiter's volume, and yet, despite this enormous size, Jupiter spins faster than any other planet, completing a full rotation in just under 10 hours. Jupiter is a gas giant with no solid surface to stand on. As you descended into its atmosphere, you'd pass through layers of clouds, first ammonia ice crystals, then ammonium hydrosulfide, and deeper still, water ice and liquid droplets. The pressure and temperature would increase continuously until the hydrogen gas becomes so compressed it behaves like a liquid metal. There's no clear boundary between atmosphere and interior, just a gradual transition into crushing depths. The most famous feature on Jupiter is the Great Red Spot, a storm so large that 2 or 3 Earths could fit inside it. This anticyclonic storm has been raging for at least 350 years. We've been observing it since the 1600s, and possibly much longer. Winds at the storm's edges reach speeds of 270 miles per hour, swirling around a center that remains mysteriously calm. The storm's reddish color comes from complex organic compounds created by chemical reactions in Jupiter's upper atmosphere, though the exact chemistry remains a beautiful mystery. Jupiter has at least 95 known moons, a miniature solar system unto itself. The 4 largest, Io, Europa, Ganymede, and Callisto, were discovered by Galileo Galilei in 1610 and are called the Galilean moons. Their discovery was revolutionary, providing some of the first evidence that not everything in the heavens orbited Earth. Europa, one of these Galilean moons, is covered in a smooth shell of water ice, crisscrossed with reddish-brown cracks and ridges. Beneath this frozen surface, tidal heating from Jupiter's gravitational pull is believed to maintain an ocean of liquid water, an ocean that contains more water than all of Earth's oceans combined. In the absolute darkness beneath Europa's ice, warmed by internal heat, some scientists believe conditions might be right for life. Io, the innermost Galilean moon, is the most volcanically active body in the entire solar system. Jupiter's gravity stretches and squeezes Io as it orbits, generating so much internal heat that the Moon's surface is constantly being resurfaced by volcanic eruptions. Some of these volcanic plumes shoot material 250 miles above the surface. Io is a world being continuously torn apart and rebuilt, painted in yellows and oranges from sulfur and sulfur dioxide deposits, a tortured moon locked in Jupiter's relentless grip. Beyond Jupiter lies Saturn, the sixth planet from the Sun and perhaps the most visually stunning world in our solar system. Saturn is the second largest planet, nearly as wide as Jupiter but much less dense. In fact, Saturn's density is so low that if you could find an ocean large enough, Saturn would float. This gas giant is composed mostly of hydrogen and helium, a massive ball of gas bound together by its own gravity. Saturn's most distinctive feature is, of course, its magnificent ring system. While all the gas giants have rings, none compare to Saturn's spectacular bands of ice and rock. The rings extend outward from the planet for about 175,000 miles, yet they're incredibly thin, in most places only about 30 feet thick. If you scaled Saturn down to the size of a basketball, its rings would be thinner than a sheet of paper, a delicate disk surrounding a giant world. These rings aren't solid structures but are composed of countless individual particles, ranging in size from tiny grains of dust to house-sized boulders. Each particle is essentially a tiny moon, orbiting Saturn independently. Most of these particles are made of water ice, which is why Saturn's rings shine so brilliantly when they catch the sunlight. The rings are bright and beautiful, a cosmic reminder that even ice can be magnificent. Scientists still debate the age of Saturn's rings. They may be ancient, formed along with Saturn itself 4.6 billion years ago, or they could be relatively young, perhaps only a few 100 million years old, the remains of a moon that wandered too close and was torn apart by Saturn's gravity. Recent evidence from the Cassini spacecraft suggests the rings might be younger than the dinosaurs, a temporary crown that Saturn wears for just a brief moment in cosmic time. Like Jupiter, Saturn also spins rapidly, completing a rotation in about 10.7 hours. This fast rotation causes Saturn to bulge noticeably at its equator. The planet is visibly flattened, about 10% wider at the equator than from pole to pole. If you could watch Saturn from a distance, you'd see it spinning like a slightly squashed ball, its rings tilted at various angles as Saturn orbits the Sun. Saturn has at least 146 known moons, more than any other planet in our solar system. The largest, Titan, is bigger than the planet Mercury and is one of the most fascinating worlds we've discovered. Titan is the only moon with a substantial atmosphere, thicker than Earth's, in fact. This atmosphere is mostly nitrogen, with clouds of methane and ethane that create weather systems remarkably similar to Earth's water cycle. On Titan's surface, the temperature is a frigid -290 degrees Fahrenheit, cold enough that water ice is as hard as rock. But methane and ethane remain liquid at these temperatures, and they rain from Titan's skies, flow in rivers, and collect in vast lakes and seas. The Cassini mission discovered lakes of liquid methane near Titan's poles, some as large as the Great Lakes on Earth. It's the only world besides Earth where we found stable bodies of liquid on the surface, though here the water would freeze solid and the rain would burn like gasoline. Another intriguing moon of Saturn is Enceladus, a small icy world only 310 miles across. Despite its size, Enceladus is one of the most reflective objects in the solar system, bouncing back nearly all the sunlight that hits it because of its pristine ice surface. But the real wonder lies beneath. In 2005, the Cassini spacecraft discovered enormous geysers erupting from cracks near Enceladus's south pole, shooting water ice and vapor 300 miles into space. These plumes revealed that beneath the frozen surface lies an ocean of liquid water, kept warm by tidal heating from Saturn's gravity. This subsurface ocean contains the basic ingredients for life: liquid water, organic compounds, and energy sources. Like Europa, Enceladus has become one of the most promising places to search for life beyond Earth, a tiny moon with an ocean hidden beneath eternal ice. Venturing deeper into the outer solar system, we reach Uranus, the seventh planet from the Sun, orbiting at a distance of about 1.8 billion miles. Uranus is an ice giant, smaller than Jupiter and Saturn but still 4 times wider than Earth. While Jupiter and Saturn are mostly hydrogen and helium, Uranus contains more water, methane, and ammonia ices in its interior, giving it a fundamentally different composition from its larger cousins. Uranus has a pale blue-green color, a serene aquamarine hue caused by methane in its atmosphere. Methane gas absorbs red light from the sun and reflects blue and green wavelengths back into space, painting the entire planet in these cool, tranquil tones. Looking at Uranus is like gazing at a distant, frozen ocean suspended in the darkness. What makes Uranus truly unique is its extreme axial tilt. While most planets spin like tops, with their axes roughly perpendicular to their orbital planes, Uranus is tilted 98 degrees. It essentially rolls around the Sun on its side. Imagine a planet lying down as it orbits, with one pole pointing almost directly at the Sun, then the equator, then the other pole in a slow, 84-year cycle. This means that each pole experiences 42 years of continuous sunlight followed by 42 years of complete darkness. Scientists believe this bizarre orientation resulted from a massive collision early in Uranus's history. Some object, perhaps as large as Earth, struck Uranus with such force that it knocked the planet over onto its side. The impact was so violent that it fundamentally changed how Uranus experiences seasons and sunlight, a cosmic accident that defines the planet to this day. Uranus was the first planet discovered with a telescope. British astronomer William Herschel spotted it in 1781, more than doubling the known size of the solar system in a single night. For thousands of years, humanity had known only the planets visible to the naked eye. Uranus's discovery revealed that there were worlds beyond what our eyes could see, hidden in the darkness, waiting to be found. Uranus has a system of 13 known rings, though they're much darker and narrower than Saturn's brilliant bands. These rings are composed of the darkest particles in the solar system, chunks of ice and rock covered in radiation-processed materials that make them nearly black. They're so faint they weren't discovered until 1977, nearly 200 years after the planet itself was found. The planet also has 28 known moons, uniquely named after characters from the works of William Shakespeare and Alexander Pope rather than Greek or Roman mythology. Miranda, one of the innermost large moons, has one of the most bizarre and varied surfaces in the solar system, a patchwork of different terrains jumbled together. It looks as though the moon was shattered by an impact and then reassembled, its pieces coming back together in a chaotic mix of canyons, cliffs, and ridges. Continuing outward to the edge of the planetary system, we arrive at Neptune, the 8th and final official planet, orbiting nearly 2.8 billion miles from the Sun. Neptune is slightly smaller than Uranus but more massive, with a deep, vivid blue color, more intense than Uranus's pale aquamarine. This striking blue comes from methane in its atmosphere, but Neptune's richer color suggests there's something else present as well, some unknown compound that deepens the blue to a darker, more mysterious shade. Neptune was discovered not by observation alone but through mathematics. In the 1840s, astronomers noticed that Uranus's orbit wasn't quite matching predictions. Something was pulling on it, perturbing its path. French mathematician Urbain Le Verrier calculated where an unknown planet would need to be to cause these discrepancies, and in 1846, German astronomer Johann Galle found Neptune almost exactly where Le Verrier predicted. It was a triumph of mathematics over observation, proof that the laws of physics could reveal worlds never seen before. Despite being the most distant planet, Neptune is surprisingly dynamic and active. The planet experiences the strongest winds in the entire solar system, with storms producing gusts up to 1,200 miles per hour, faster than the speed of sound on Earth. These supersonic winds race around the planet in the opposite direction of its rotation, driven by internal heat that Neptune radiates from deep within. Even so far from the Sun's warmth, Neptune generates its own energy, remaining restless and turbulent. Neptune has 16 known moons, the largest of which is Triton, a world nearly as large as Europa. Triton is one of the coldest objects in our solar system, with surface temperatures around -390 degrees Fahrenheit, yet it's geologically active. The Voyager 2 spacecraft observed geysers of nitrogen gas erupting from Triton's surface, shooting material 5 miles into the thin atmosphere. Even in this frozen realm, billions of miles from the Sun, worlds remain alive with activity. What makes Triton especially unusual is that it orbits Neptune backward, in the opposite direction of the planet's rotation. This retrograde orbit tells us that Triton wasn't born around Neptune but was captured, likely pulled from the Kuiper belt by Neptune's gravity. Triton is a wanderer that came too close and was claimed by Neptune, now locked in orbit around the blue giant, slowly spiraling inward over millions of years. Beyond Neptune lies a vast region called the Kuiper belt, a disc-shaped zone extending from Neptune's orbit outward to about 5 billion miles from the Sun. This region is populated by countless icy bodies, remnants from the solar system's formation that never came together to form a planet. The Kuiper belt is home to dwarf planets, comets, and frozen worlds that preserve the ancient conditions from when our solar system was young. Pluto, once considered the 9th planet, resides in the Kuiper belt at an average distance of 3.7 billion miles from the Sun. It's a small world, only about 1,400 miles across, smaller than Earth's moon, but it's surprisingly complex. When NASA's New Horizons spacecraft flew past Pluto in 2015, it revealed a world of stunning beauty: vast plains of nitrogen ice, towering mountains of water ice as hard as rock, and a thin atmosphere that freezes and falls to the surface as Pluto moves away from the Sun in its elliptical orbit. Pluto has 5 known moons, the largest being Charon, which is about half Pluto's size. Charon is so large relative to Pluto that the two worlds orbit a common point in space between them. They're essentially a binary system, two worlds locked in an eternal dance. Pluto and Charon always show the same face to each other, tidally locked, rotating together as they journey through the outer darkness. The Kuiper belt is also the source of many short-period comets, those cosmic snowballs that occasionally venture into the inner solar system. When gravitational interactions send a Kuiper belt object sunward, the Sun's heat causes its ices to vaporize, creating the glowing coma and spectacular tail that make comets so distinctive. These visitors from the outer reaches bring with them pristine ice and organic compounds from the dawn of the solar system. Beyond the Kuiper belt lies an even more distant region called the Oort Cloud, a vast spherical shell of icy objects surrounding our entire solar system. The Oort Cloud extends from about 2,000 times Earth's distance from the Sun out to nearly halfway to the nearest star. It's so distant that objects there take millions of years to complete a single orbit around the Sun, moving through the darkness at the very edge of our Sun's gravitational influence. The Oort Cloud is thought to contain trillions of icy bodies, potential comets waiting in the darkness. Occasionally, a passing star or gravitational disturbance nudges one of these objects inward, sending it on a journey that may take thousands or millions of years, until it finally enters the inner solar system as a long-period comet. These comets might visit the Sun just once in recorded human history, appearing suddenly in our skies before returning to the darkness from which they came. Our solar system is constantly in motion through space itself. The Sun, along with all its planets, moons, and countless smaller bodies, is traveling through the Milky Way galaxy at a speed of about 450,000 miles per hour. Even at this incredible velocity, it takes our solar system approximately 225 to 250 million years to complete one orbit around the galactic center, a period sometimes called a cosmic year or galactic year. This means that since the Sun formed 4.6 billion years ago, our solar system has completed only about 20 orbits around the galaxy. The last time we were in this position in our galactic orbit, dinosaurs still roamed the Earth. The solar system moves through space like a vast ship sailing through an ocean of stars, carrying us all on a journey we rarely contemplate. The solar wind that streams outward from the Sun eventually encounters resistance from interstellar space, the region between stars. This boundary, called the heliopause, marks where the Sun's influence ends and true interstellar space begins. It's located roughly 11 billion miles from the Sun, nearly 4 times farther than Neptune. In 2012, Voyager 1 became the first human-made object to cross this boundary, entering the space between stars. Within our solar system, there are more than 200 known moons orbiting the various planets. These moons come in extraordinary variety. Some are captured asteroids, small and irregular. Others are large, spherical worlds with complex geology. Some have atmospheres, subsurface oceans, or active volcanoes. Each is a world unto itself, with its own story written across its surface. The asteroid belt contains not just rocky debris but also metal-rich asteroids, remnants of the cores of planetesimals that were shattered by collisions billions of years ago. Some of these asteroids contain more iron, nickel, platinum, and gold than have ever been mined on Earth. They're the broken hearts of worlds that never finished forming, now drifting in the space between Mars and Jupiter. Comets are often described as dirty snowballs, mixtures of ice, dust, and organic compounds left over from the solar system's formation. When a comet approaches the Sun, the ice doesn't melt but sublimates, turning directly from solid to gas. This process releases dust and creates the characteristic tail, which always points away from the Sun regardless of the comet's direction of travel, pushed by solar radiation and the solar wind. Some of the most spectacular meteor showers we see from Earth occur when our planet passes through the debris trail left by a comet. The Perseid meteor shower in August, for instance, is caused by Earth moving through particles left behind by Comet Swift-Tuttle. As these tiny fragments, some no larger than grains of sand, enter our atmosphere at speeds up to 130,000 miles per hour, friction with air molecules causes them to burn up, creating the shooting stars that streak across our summer skies. The solar system contains several regions where asteroids collect due to the gravitational influence of Jupiter and the Sun. These are called Lagrange points, specific locations where the gravitational forces of two large bodies balance perfectly. The Jupiter Trojans are two large groups of asteroids that orbit the Sun in Jupiter's path, one group traveling ahead of Jupiter and another following behind, trapped in these stable gravitational pockets. Throughout the solar system, ice exists in many forms and many places. Beyond the obvious ice caps on Mars and the icy moons of the outer planets, water ice has been found in permanently shadowed craters at Mercury's poles, beneath the surface of asteroids, in comets throughout the Kuiper Belt, and even as frost on Pluto's mountains. Water, in its frozen form, is one of the most common substances in the outer solar system, a testament to how prevalent the building blocks of life truly are. The Sun itself has a dynamic atmosphere with distinct layers. The visible surface we see is called the photosphere, but above it lies the chromosphere, a reddish layer visible during solar eclipses, and beyond that, the corona, an ethereal crown of superheated plasma that extends millions of miles into space. Mysteriously, the corona is far hotter than the surface below it, reaching temperatures of several million degrees. Scientists are still working to understand why the corona is so much hotter than the Sun's surface, a puzzle that defies our intuitive understanding of heat flowing from hot to cold. Every 11 years, the Sun goes through a cycle of activity, transitioning from solar minimum to solar maximum and back again. During solar maximum, the Sun's surface becomes covered with sunspots, dark patches caused by intense magnetic activity, and solar flares and coronal mass ejections become more frequent. During solar minimum, the Sun appears calmer, with fewer sunspots and less dramatic activity. This cycle has been observed for centuries, a rhythm in our star's behavior that influences space weather throughout the solar system. The planets in our solar system all orbit the Sun in elliptical paths, not perfect circles. Some orbits are nearly circular, like Venus's, while others are more elongated. Pluto's orbit is so elliptical that for about 20 years of its 248-year journey around the Sun, it's actually closer to the Sun than Neptune. The last time this occurred was from 1979 to 1999. For those 2 decades, Neptune was temporarily the most distant planet. Our solar system is just one of billions of planetary systems in the Milky Way galaxy. We've now discovered thousands of exoplanets, planets orbiting other stars, and each discovery reveals that planetary systems come in endless variety. Some have gas giants orbiting closer to their stars than Mercury orbits our Sun. Others have multiple planets in the habitable zone. The universe is far more diverse than we once imagined, and our solar system is just one example of how stars and planets can arrange themselves. Earth's axis is tilted at about 23.5 degrees relative to its orbital plane, and this tilt is responsible for our seasons. As Earth orbits the Sun, different hemispheres receive more direct sunlight at different times of year. When the northern hemisphere tilts toward the Sun, it experiences summer while the southern hemisphere experiences winter, and vice versa. Without this tilt, we would have no seasons, just endless, unchanging climate zones based purely on latitude. The largest volcano in our solar system isn't on Earth but on Mars. Olympus Mons, which we mentioned earlier, is so massive that if you stood on its summit, the base would extend beyond the horizon in every direction. The volcano is so wide, about 370 miles across, that its gentle slopes would make it difficult to even realize you were on a mountain. It's a shield volcano, built up over millions of years by countless eruptions, layer upon layer, until it became a monument visible from space. Saturn's moon Iapetus has one of the strangest features in the solar system, a massive ridge that runs along its equator, circling nearly halfway around the moon. This ridge rises 12 miles high in places, making Iapetus look somewhat like a walnut. Scientists aren't certain how this ridge formed, but it gives Iapetus an appearance unlike any other world we've discovered, a perfectly positioned mountain range that follows the equator as if placed there deliberately. Jupiter's moon Ganymede holds a special distinction. It's the largest moon in the entire solar system, even larger than the planet Mercury. Ganymede is the only moon known to have its own magnetic field, suggesting it has a liquid iron core deep within. Beneath its cratered, icy surface, Ganymede is believed to harbor a subsurface ocean containing more water than all of Earth's oceans combined. Even in the cold depths of the outer solar system, liquid water persists, hidden beneath frozen shells. The speed of light, while the fastest thing in the universe, still takes time to cross the vast distances of our solar system. Light from the Sun takes 8 minutes and 20 seconds to reach Earth, but it takes over 4 hours to reach Neptune. When we look at Neptune through our telescopes, we're seeing it as it was 4 hours ago. The solar system is so vast that even light must journey patiently from one world to another. Throughout the solar system's history, the planets haven't always been where they are now. Scientists believe that during a period called the Late Heavy Bombardment, about 4 billion years ago, the giant planets migrated, shifting their positions and sending countless asteroids and comets careening through the inner solar system. Jupiter may have formed farther from the Sun and then moved inward before settling into its current orbit. The planets themselves have wandered, their positions shaped by gravitational interactions and the chaotic early days of our cosmic neighborhood. Earth has experienced 5 major mass extinction events in its history, and asteroids or comets have played a role in at least one of them. About 66 million years ago, an asteroid roughly 6 miles across struck the Yucatan Peninsula, creating the Chicxulub crater and triggering environmental changes that led to the extinction of the dinosaurs. This impact was a reminder that Earth exists in a shooting gallery, surrounded by debris that occasionally finds its way to our world. Yet these impacts have also brought water and organic compounds to Earth, the very ingredients that may have made life possible. Our understanding of the solar system continues to evolve. New moons are discovered regularly around the giant planets. Spacecraft continue to reveal surprises, like the heart-shaped plane on Pluto or the hexagonal storm at Saturn's North Pole. Every mission, every observation adds detail to our cosmic portrait, reminding us that even in our own celestial neighborhood, mysteries remain. The solar system is a testament to the forces of gravity, chemistry, and time. It's a laboratory where we can study planetary formation, atmospheric dynamics, and the potential for life beyond Earth. Each world, each moon, each ring and asteroid tells part of the story, a story that began in a collapsing cloud of gas and dust 4.6 billion years ago and continues today. And so our journey through the solar system comes to a close, at least for now. From the blazing surface of the Sun to the frozen darkness of the Oort Cloud, We've traveled across billions of miles, visiting worlds of fire and ice, gas and rock, worlds with rings and moons, volcanoes and oceans hidden beneath ancient ice. Each of these worlds is real, existing right now as you listen to these words. Jupiter's great red spot is still swirling. Saturn's rings are still catching the sunlight. Geysers are still erupting on Enceladus, and the sun is still fusing hydrogen into helium, as it has for billions of years and will continue to do for billions more. We are part of this grand system, citizens of Earth but also residents of the solar system, participants in this cosmic dance. When you look up at the night sky and see Venus shining brightly, or Mars with its reddish glow, remember that these are places, actual worlds with landscapes and weather, with histories written across their surfaces. The solar system is our home on the largest scale, a collection of worlds bound together by gravity and shared origin, all orbiting the same star, all made from the same ancient cloud. We've only just begun to explore these worlds, sending robotic ambassadors to our planetary neighbors, but one day, perhaps, humans will walk on Mars, float in the clouds of Venus, or dive beneath the ice of Europa. For now, we can dream, we can wonder, and we can look up at the stars, knowing that we're part of something vast and beautiful, a solar system, our solar system, forever turning through the darkness, a brilliant island of light in the cosmic ocean. Rest well, fellow traveler. The universe waits patiently for us to continue exploring.